Hi, good day everybody. I'm Lim Hong from 3SESB. So today Lim is here to present my FYP title with the title with an improved deep neural network algorithm for the prediction of the limited proteolysis in the native protein. So my supervisor is Dr. Hasina bin Hashim. So let's have a look of my topic. So it will start with introduction, followed by literature review, methodology, experimental setup, and end with conclusion. So let's start now with the introduction. So in this study, so the domain of the study is about the proteases. So what is proteases? Proteases are known as peptidase or known as proteinase. Uh, so they are proteolytic enzymes that hydrolyze the peptide bond at the cleavage site in their substrate. So in a simple word, is a enzyme for digest protein. So what is the problem about the proteases? So proteases will undergo fertility event to cleave the substrate into a product at a specific site. So the process normally you are known as hydrolysis. So through the fertility event, we can discover the functional protease cleavage site, or in a simple word called nick site, so that we can know that at which site the protein will be cleaved by the proteases. So what is the aim of the study? The aim of the study is to introduce and improve deep neural network algorithm to identify the next site. So after my study during this SEM, so I discovered a method called SMO-DNN algorithm. So in this PSM, I propose that I will use the SMO-DNN algorithm to solve the problem. So the problem is we need to find the next site. So the objective of this study is the first one, to investigate the improved deep neural network that can be used to identify the functional protease cleavage site, or known as NIC site. So the second one is to apply the algorithm to identify the functional protease cleavage site. And the third, to validate the performance of the algorithm. So in a simple word, the first one is to investigate, the second one is to apply, and the third one is to validate. So in this proposal, only the first one objective is achieved, which means I investigate a method called SMO-DNN to solve the problem. So the second and the third objective are expected to achieve during the PSM2. So now let's move on to the literature review. So of course our domain is proteases, so we must start with the proteases. So from my study, there are 6 types of the proteases. There are aspartic proteases, cysteine proteases, metalloproteases, serine proteases, threonine proteases, and glutamic proteases. So each type of the proteases are explained in my proposal in details. So overall, in each type of the process, I will explain the definition, the mechanism of action, and the characteristic, and so on. So as you can see from this the hydrolysis, so the proteolytic event that I mentioned previously. So it will cleave at, normally the proteases will cleave the CONH bond, or known as the peptide bond, and it will yield the peptide and the amino acid. So after introduce the proteases, I also introduced the proteases database, or known as MEROP database. This is the source of information that available for the proteases. So the database is built by the Rawlings and his co-workers. So in the database, they are structured in hierarchical. So it will have plant, family, species, until the bottom one is the proteases protein. So this is the structure in the mirror database. Next, I will introduce a fertility event named limited proteolysis. According to the definition, it is the process that irreversible process that click on very specific and limited substrate only. So we may cause the specific change of the protein function. So through my research, there are 6 parameters, or in a simple word, we name it as factors that will affect the limited proteolysis. The first one is the solvent accessibility. Second one is proteation index. The third one is residue average temperature factors. The fourth one is oil number. The fifth one is the secondary structure of the protein, and the sixth is the main chain hydrogen bond of the protein. So let's have a brief understanding on it. So the first one, solvent accessibility, is to describe how accessible the particular solvent molecule can come into contact with the variable force. So through my literature review on the other researcher papers, so they proved that 1.4 ampere probe is used. So the second one is the proteation index. Protection index is the approximate measurement on the protein shape. However, it's only a weak indicator since the shape of the protein are not all the same. So some are in the non-ellipse order. So if the shape is in non-ellipse order, so the protection index are not a perfect measurement on it. So the third factor is the temperature. So the temperature will describe how mobile the molecule can be moved. So in a simple word, we say that the higher mobility has a higher tendency to launch the proteolytic attack. Thus, the limited proteolysis were more likely to be occurred by the temperature factors. So let's move on to the next page. Of the fourth one is the OI number. OI number describes the number of other alpha carbon atoms within a fixed radius of the residues of other alpha carbon. The larger the OI number, the better the result in terms of the correlation. So through my study, we found that 14 ampere will be used in the experiment will be perfect. So the fifth factor is the secondary structure of the protein. Although it is not the prevalent for the next site precision, however, the three basic structural states of the secondary structure, which helix, coil, and beta stranded, can be scored. So finding showed that the optimal condition for the discriminate next site from the structure are 4 standard states of the helix 0.5, strand 0.0, coil 1.0, and disulfide linkage penalty of 0.4. So in the last parameter is the main chain hydrogen bonding. So score is taken from the hydrogen bonding. So from the study, it showed that the hydrogen bond was quantified by a cut distance below 3.5 ampere with an angular cut-off above of 90 degrees at a minor hydrogen, excluding the heteroatoms. So the evaluation for the possible loop length were used are 6, 8, 10, and 12. But in my study, I plan to use 10 residues. Now, since my method used is a deep learning, so I will introduce the machine learning at first. So according to the author Samuel, which the person who coined the word for machine learning, he said that machine learning is the field of study that gives the computers the ability to learn without being actually programmed. So in a simple word or normally definition, we say that machine learning is the branch of the artificial intelligence that systematically applies algorithms to synthesize the underlying relationship among the data and the information. So our machine learning can be subdivided into 3 types. The first one is the supervised learning, second one is unsupervised learning, and the third one is reinforcement learning. So after introduce the machine learning, so now we're going to introduce some common machine learning methods. So the first one is the support vector machine, or known as SVM. It is an supervised learning that uses the Warnick Seronetis, or known as VC theory, normally applied in the classification, regression, and anomaly detection. So another famous method named random forest. So it is the supervised learning method that uses the collection of trees as a classifier, which is responsible in the classification and regression as well. So the third common famous machine learning method is neural network. So the basic unit of the neural network is neuron. So it will transfer the impulse from one to another. So it has the structure that there are input neurons that will perceive the environment, then it will process the information inside him, and if reach the threshold, it will give the output to trigger the actions. So neural network it can be more advanced to become the deep neural network, or known as DNN. So what is the difference between the neural network and the deep neural network? Let's have a look on the picture. So from this picture is the normal ANN. So the neural network. So the difference is the deep neural network it consists more hidden layers compared to the normal neural network. So due to have more the hidden layers, it believes that it can learning more feature if it is well trained. So this is due to this reason, nowadays it become among the famous method in machine learning. Let's first go back to our topic today. So the topic of the PSM is an improved deep learning method for the prediction of the next step. So let's go back to our domain problem. So our problem is the proteases. So from my research, we can tell that all the famous methods mentioned just now, the SVN, RF, and the DNN are widely used in any aspect, including the identification of the next site. So this inspired me to make a different approach to study the same problem. So as mentioned in the objective just now, I identified a improved DNN method called spider monkey optimization and deep neural network hybrid, or in the short form SMO-DNN. So by using this algorithm, I believe that it will reduce the execution time and the energy consumption if compared to the normal DNN. So it is a new method that can be considered to identify the niche set. So let's have a look on the diagram. So this is the swarm intelligent concept that built out the SMO-DNN model. So it will use the division of labor and the self-organization. So by these two elements, then it will help us to make an intelligent decisions. Okay, let's move on to the machine learning method review. So this the SVM, random forest, DNN, and SMO-DNN. So in this literature review, it will explain about the description, the references that I refer, and its pro and its cons. So let's move on to the next part. So because after identify the method, we must have a platform to run the experiment. So I use the cloud computing. So cloud computing is the online service that provides addressing computer infrastructure and other resources. So from this study, I will use GCP, which is Google Cloud Platform, compared to AWS, which is Amazon Web Service, because it's cheaper, better in handling traffic spike, support large disk size, and has the private network. So let's move on to the methodology. So in my methodology, I consist of a series of workflow. So it will start with the literature review that I described previously. Then in the phase 2, it has the improve deep neural network as the classification algorithm. So in here we consist of data collection, data cleaning, sample selections, feature data collection and calculation, and classification algorithm implementations. So in the phase 3, we we will evaluate the algorithm just now. So in this study, I will use the confusion matrix. Then I also use another parameter such as accuracy, precision, specificity, sensitivity, and F1 score, and area under the curve to measure the performance of the algorithm just now. So in the chapter 4 with experimental setup, I consider a workflow. So the workflow is start with the data preparation. So first we receive the data, then identify the positive and negative sample. Then I will undergo the feature selection to remove unnecessary attribute, and the edited data are then being trained and tested, and the process is end after that. So in conclusion, because LIM is first time to do the research, so definitely there are many circumstances. So the first one is LIM are not familiar in handling the data sets. So the second circumstance is because the famous method have been widely used, so it make a different from the previous work of the other researcher is difficult. So the to make the difference, LIM choose to find another method to undergo the same problems. So the third one is apply code during experiment in data. So as mentioned before, the objective achievement, only the first objective is to achieve, which is investigate and improve DNN method to identify the next site. So in this study, LIM plan to use the SMO-DNN algorithm to solve the problem. Okay, thank you for listening today. Thank you everyone.